Now we will be looking at another numerical example and try solving it together. So, are you up for it? Let's do it. We have 10 gram of phosphoric acid. It has been dissolved in excess water H2O to dissociate it completely into its ions. There are 4 steps to this question. We are required to calculate the number of molecules in 10 grams of phosphoric acid, then the numbers of positive and negative ions in case of complete dissociation in water. The third part is to calculate the masses of individual ions, and the last part says to calculate the number of positive and negative charges dispersed in the solution. Let's start with the first part, where we are required to calculate the number of molecules in 10 grams of phosphoric acid. So, for the first part, as you can notice, we have been given the mass of phosphoric acid, which is 10 grams. And to calculate the molar mass, we need to know the number of atoms for each element in the molecule. You see that we have got 3 atoms of hydrogen. So, it will be 3 multiplied by 1 gives us 3, plus you have got 1 atom of phosphorus, which is 31. Then we have got 4 atoms of oxygen. So, it will be 16 multiplied by 4, which is 64. And when we add all these together, we get 98, and that will be the molar mass of phosphoric acid. Now, we know the formula for the number of molecules, which is mass of phosphoric acid divided by molar mass of phosphoric acid, and then we multiply this by the Avogadro's number, which is 6.02 into 10 to the power 23. So, now putting the values in the formula, we get 10 divided by 98 multiplied by 6.02 into 10 to the power 23, and by solving it on the calculator, we get the answer as 6.14 into 10 to the power 22 or 0.614 into 10 to the power 23. Both the answers are correct. Now that we have developed an understanding of this, let's move on to the second part, where we are required to calculate the number of positive and negative ions. First off, we need to see that when phosphoric acid will dissolve in water, what ions are going to be produced. Any guesses? Well, let's get to it. 3 moles of hydrogen ions H plus 1 mole of phosphate ion PO4 3 minus. So, we have 3 ions of hydrogen H plus and 1 phosphate ion PO4 3 minus. Can you recall how in the first part we calculated how many molecules we have for this sample, which was 6.14 into 10 to the power 22. Now, we will simply multiply this number with 3 and will get 1.842 into 10 to the power 23, which will be the number of hydrogen ions H plus for this sample. In the same manner, we know that 1 molecule of phosphoric acid gives 1 phosphate ion PO4 3 minus. Hence, for 6.14 into 10 to the power 22 molecules, we will have 6.14 into 10 to the power 22 number of phosphate ions. This is exactly similar to what we discussed in the previous video. Does it ring a bell? Now that we have solved this part, shall we move on to the third part, where we are required to calculate the masses of individual ions? Well, we know about 2 ions, hydrogen ions H plus and phosphate ion PO4 3 minus. The number of hydrogen ions will be calculated using the formula. The total mass of hydrogen ions H plus divided by ionic hydrogen ions H plus, as we have reached this formula to calculate the total mass of hydrogen ion H plus. It will become the number of hydrogen ion multiplied by the ionic mass of hydrogen ion divided by the Avogadro's number. Now let's insert the values in the formula and we will get 1.842 into 10 to the power 23, which is the number of hydrogen ions multiplied by 1.008, that is the ionic mass, divided by 6.02 into 10 to the power 23, which is the Avogadro's number. Are you getting what we did here? Upon solving this calculation, we will get 0.308 gram, which would be the total mass of H+. Once that is done, how about we calculate the total mass of phosphate ion PO4 3- using the same formula. We will have the total mass of phosphate ion divided by the ionic mass of phosphate ion multiplied by the Avogadro's number. In the same way, we will rearrange the formula to find out the total mass of phosphate ion, and after entering the values, we will get 6.14 into 10 to the power 22 multiplied by 95 divided by 6.02 into 10 to the power 23. Upon solving it, this gives us 9.689 grams, which would be the total mass of phosphate ions. Is this clear? This brings us to the last step of this numerical, which is to find the number of positive and negative charges dispersed in the solution. So, one molecule of phosphoric acid gives 3 positive charges in the solution, as we have 3 ions of hydrogen, right? Hence, it will become 3 multiplied by 6.14 multiplied by 10 to the power 22, which is the number of molecules. On solving this, we will get 1.842 into 10 to the power 23 positive charges. Since the numbers of positive and negative charges are always equal, so automatically the number of negative charges becomes 1.842 into 10 to the power 23.